S. Chan presents educational video lectures as per the new UGC CBCS curriculum. Absolutely free. Difficult concepts made easy. Study anywhere, anytime.
Do you know, if we are moving from one point to another, whether it is a small change, we are doing maths. So today we will be reading this differentiability, and differentiability gives you the rate of change. It means it will give you the movement from one point to another point. Hello everyone, I am Dr. Seema Thakaran. Welcome to S. Chan Academy. If you want to study this topic in detail, you can refer to the book by S. Chan Publishing. The e-book link of which is mentioned in the description box below. In this lecture, we will be studying differentiability of functions. So, as I have already explained or told you, this topic is important whenever you you want to know the rate of change of any function or anything. You will be knowing differentiability and how you calculate the derivative or differentiability. I will be just teaching you. So, let us start with differentiability of a function. Again, as I told you in the continuity also, function should be well defined if you are checking this differentiability of a function at any point. So, let us again for the definition, in brief I will be writing, let f from the domain is AB, this is the function, and let x equal to C be the point in AB. It means you are considering the domain point, and for definition, how you will be checking the differentiability. So, it means for the differentiability, the left hand derivative should be equal to the right hand derivative. If you at this point, if you want to say that the function is differentiable, it means left hand derivative. What does it mean now? Again, the limit concept you should be knowing. So, how we define the left hand derivative? Just be careful, in limit and continuity it was different, but for derivative it is, the definition is this. It means the function and the value of the point function at that point and the difference of x minus c in the denominator. This should be equal to x tending to the right hand limit will be, it just approaching to the right hand side of the point. If these two limits are equal, now we are not discussing, we are not bothering. In continuity we have three limits, left hand limit, right hand limit and f of c, the value of the function at that point. But for differentiability, it just only left hand derivative should be equal to the right hand derivative if you are checking the differentiability at that point. So, this is the definition of differentiability. Now, the very important thing is that before checking differentiability or coming to the questions, you should be knowing this statement that every differentiable function is continuous. It means if your function is differentiable, it will 100% continuous and not conversely, not other way around, not conversely. So, one example, not conversely means if you have a continuous function, every continuous function may or may not be differentiable. So, you should be knowing this concept if you want to master differentiability. आपको ये पता होना चाहिए कि अगर फंक्शन डिफरेंशिएबल है वो कॉन्टीन्यूस होगा. इट मीन्स अगर फंक्शन डिफरेंशिएबल है तो कोई ब्रेक नहीं होगा ग्राफ में. लेकिन इफ़ यू ओनली नो दैट द फंक्शन इज कंटिन्यूस देन इट मे और मे नॉट बी कि वो फंक्शन डिफरेंशिएबल हो. वेरी फर्स्ट एग्जाम्पल ऑलरेडी आई कंसिडर्ड इन माई लास्ट लेक्चर. Again I am considering because it is a good question, a good example to quote here. So fx is mod x for all x in R, and graph also I just draw. This is the graph of this curve or this function. This is the graph. Now why I have drawn this graph, because if you know if you can draw the graphs na, of any function, by looking at the graph you can easily figure out whether the function is differentiable or not. You see this edge you can see at this point. If there is a edge at any point, you will say that the function is not differentiable at that point. So graphically also you can see there is a edge, so it is not differentiable. But how you will see theoretically? So let's start. What to do to check? I will be considering the left hand derivative first. And what is the definition? Limit. क्या definition थी कि आप उस point के 0 पे checking करेंगे, because 0 पे ही आपको दिखाई दे रहा है. Rest point पे there is no issue, there is no edge. So it means graphically only at 0 there is a problem. So 0 पे जब आप देखोगे left side fx minus f0 upon x minus 0. First I will be calculating this. So left hand derivative, how to calculate? Obviously you should be knowing first, because mod x function is not that, it is always positive. Already in the first lecture we have mentioned it. So it will be taking x values if x is positive. If x is negative, then you put a negative sign, then it will become positive. So it will be completely positive, and this is the definition. So left side 0 minus, you can see from the definition, it is the function is in split form. X negative side you are moving and minus x is the value. So minus x and f of 0 clearly 0 upon x. Sometimes what you do, you just put the value directly 0 by 0. No, don't do it. First simplify, then put up the limit. You should never be putting the limit directly. So minus x by x, it is giving you minus first, because this gets cancelled. So directly minus 1 you are getting. Now calculate right hand derivative, and for the derivative obviously you are calculating the limit. Fx minus f0, this definition you will be remembering when you are calculating. So it is fx, the value of the function at that point, then x minus 0. Now for the right hand limit, what is the value? You can see for the right hand side it is positive. So x minus 0 upon x minus 0 and limit x tending to 0. Simply again it is x by x getting cancels 1. So you can see the left hand derivative, clearly it is not equal to the right hand derivative. So you can simply say the function is not differentiable. So by graphically I told you, if there is a corner in the graph, you will say ki not differentiable if you good enough in tracing the curve, or if you are not, then by the definition, theoretical definition, you can move. Left hand derivative you will calculate, right hand derivative you will calculate, and if they are not equal, not differentiable. If they are equal, they will be differentiable. So this is the example of not differentiable. And you see one more thing, as I told you one important fact about differentiability now, this function is continuous. This function is continuous but not differentiable. As I told you na, that if it is differentiable, it will be 100% continuous, but it is not. If any function which is continuous may or may not be differentiable. This is the one of the best example to quote here, or this is the only example which basically is suitable for this statement. So you just remember this. Many a times it is asked, give one example which is continuous, not differentiable. So you can quote or you can state this example. Now moving to, because already we have considered differentiable function. So let's not differentiable function basically. I will just take one example, and that is simply the greatest integer function. A function which is not continuous, even not differentiable. Because if a function, okay, let me write the statement again. As I told you, f is differentiable is implies continuous. It means not continuous implies not differentiable. And try to understand this thing. Function differentiable implies continuous, but not continuous understood that it will not be not differentiable. So, this is the example, and for all x belonging to R. Now, I am just limiting this question to one interval, otherwise I can take it for all real values, but better I just fix it in one interval. So, how I will be, first I will be just defining this greatest integer function, how basically this function is defined. So, let me break the interval. First I will be considering till from 0 to 1, this is the breaking, then 1 to 2. You have to break this interval for particularly this question, particularly for this greatest integer function, otherwise you cannot solve. So, what does it mean? Greatest integer function means 0 to 1 are the values, 0 to 1 but not taking 1. So, below this the values are 0 0.2, 0 0.1, which is the integer which is greatest and coming in this interval, that is 0, 1 is not coming. So, integer and near greatest, it should be greatest and it should be below 1. So, that is only 0, that is the greatest integer, and for particularly for this 1 to 2 interval, again 1 will be the greatest integer, and for 2 to 3 it will be 2. Now, you just see. So, we have defined greatest integer. I will draw this function also. Graphically also you will get to know. So, now see 0 to 1, this is my 0, this is 1, this is 2, this is 3. So, 0 to 1 it is taking 0 values. So, it means I just dark this line. Now, 1 to 2 it is 1 only. Again it is not covering 2, and then 2 to 3 it is 2 only. So, this is 2, this is 1. You can see the breaks clearly. So, breaks are there, it means the function is not continuous at 1, not continuous at 2. Now, clearly from the graph, function is not continuous at x equal to 1 and 2. I will be checking, I will be showing you that if it is not continuous, understood it is not differentiable 101%. So, let us start with checking the differentiability part. So, I will be checking at 1 x equal to 1, after the then you will be checking at x equal to 2, and after the break I will be telling you how to check, or whether your answer is correct or not, you can check. So, let us left hand derivative at x equal to 1. So, as per the definition, it will be x 1 minus, it means you will be moving to the left of 1, then f of 1 x minus 1. So, now in 1, when you are moving to 1 left of 1, what it is giving you? 0. What is f of 1? F of 1 is 1, and then limit x tending to 1 minus, and then x minus 1. So, when you are substituting the value 1, fx is, you can clearly see left hand side you are moving, it is giving you 0. Then f of 1 is clearly from this definition, it is 1 only. So, it is limit x 1 minus 0 minus 1. No need to put a negative sign here, already you have considered the negative side. So, minus 1 upon x minus 1. So, this is basically approaching to minus infinity, because minus 1 upon this, and this is giving you minus infinity. Now, I will be checking the right hand limit at this particular point. I just keep this. So, now right hand limit x tending to 1 positive side, fx minus f of 1 x minus 1. So, again from the definition x1 plus, what was it? 2. It was when you are moving to one positive side, you can see one positive side is, it is 1 and f of 1 is 1. So, it is 0. So, this side it is 0, it means it is 0 because 0 by something is 0 and that is a finite number. So, 0 and minus infinity, you can see the left hand limit is not equal, left hand derivative not equal to the right hand derivative in this case. Simply you will say the left hand derivative not equal to the right hand derivative. The same thing will happen at x equal to 2. You can check the same way, you can check and you can verify. If it is not continuous, it will not be differentiable. Now, we will be continuing after the break and I will be taking some important useful facts about differentiability and side by side for continuity.
हेलो स्टूडेंट्स, मेरा नाम आदित्य है और मैं आ रहा हूँ एस चांद एकेडमी पर आप लोगों के लिए जूलॉजी की स्पेशल वीडियो सीरीज़ लेकर। आप जानते हैं कि जूलॉजी एनिमल्स के रिलेटेड एक साइंस है जिसमें आप बहुत डाइवर्स टॉपिक्स पढ़ते हैं और इनमें कुछ टॉपिक्स ऐसे होते हैं जिनमें आपको अक्सर प्रॉब्लम्स आती हैं, अक्सर चैलेंजेस आते हैं। पिछले करीब 10 सालों में मैंने रिसर्च और मास्टर्स, बीएससी इन सब के दौरान इन सारे टॉपिक्स को बहुत अच्छे से पढ़ा, समझा और इसी एक्सपीरियंस को लेकर मैं आपके सामने आ रहा हूँ। बहुत इंटरेस्ट आपको आएगा और बहुत ही सिंप्लीफाइड मैनर में आपको वीडियोस मिलेंगे। सो प्लीज़ डू सब्सक्राइब टू एस चांद टू गेट कंटिन्यूअस अपडेट्स। आपको लगातार अपडेट्स मिलते रहें, आप नए नए वीडियोस को लगातार देखते रहें ताकि आपकी नॉलेज का एनहांसमेंट हो और साथ ही साथ आप एग्ज़ाम ओरिएंटेड तैयारी भी कर सकें। थैंक यू वेरी मच।
Welcome to S. Chand Academy. Now, before break we studied differentiability definition, then differentiability and continuity relation. So, one of the important factors, every differentiable function is continuous but not conversely. It means a continuous function may or may not be differentiable. Examples I have already discussed before the break. Now, I will start important results on differentiability. So, let us start. So, results on differentiability. What basically, suppose if you have two functions, let f from this is your f and two functions we are considering, f from f and g, and you can see both the domains are same. It's not that you are considering two functions, domains are different. It is not like you cannot discuss anything on those two functions. So, a domain should be same. If you have two functions same domain and they both are differentiable, then what you can conclude directly that their sum and difference will also be differentiable. So, this is very easy to check now. If you know f is differentiable, g is differentiable, then their sum and difference automatically will be differentiable, will also be differentiable. Then again, if two functions are differentiable, their product, not composition, their product will also be differentiable. And the last is that if you will take the division, but for division you have to be very particular that the denominator function, that is gx, it should not be equal to 0, then this division function will also be differentiable. So, and in continuity part I did not discuss these results. Those same results holds for continuous functions because every differentiable function is continuous. It means these results hold for differentiable functions. It means they will be true for continuous functions. So, the same properties will go for continuous functions. So, it means if f and g are continuous, no need to check the sum and the difference, it just check the separate two functions continuity. So, if f and g continuous functions, CTS for continuous function, then their sum, their product and the division will also be, all the relations, all these expressions will be continuous. So, because of differentiability, if you are good enough in checking the differentiability, no need to check the continuity part. It will be very easy for you. If you know the differentiability, you can easily say that the function will also be continuous easily. I am taking one of the very most important example, and it comes in competitive exams so many times. Then in general also I will let you know how to figure out if any problem of this time coming. So, the question is x square sine 1 by x when x is not equal to 0. When x is 0, the function is 0. For differentiability and continuity of this function, I will be checking. In my previous lecture, I checked x sine 1 by x, limit was existing, it was f of 0 is 0. So, this function is continuous. Please make it sure that before going to differentiability, it is always better you check continuity part. Why? Because if the function is not continuous, no need to go for differentiability, it will 100% be not differentiable. So, now this function is continuous. In my previous lecture, I have already calculated, I have already showed you that this function is continuous, no issues with the continuity. It means, but you cannot directly say, now if it is continuous, you cannot say that this function will be differentiable, because continuity does not imply differentiability. Differentiability implies continuity. It means a continuity is there, इस function में continuous है, but अब आप directly नहीं कह सकते कि ये differentiable होगा. So, you have to check differentiability, and at 0 only I am checking. So, for differentiability what we do? The simplest fact we are applying, left hand derivative will be checking. So, left hand derivative definition was limit x tending to this, the function fx and f0. F0 you can see clearly from the function definition. This is this limit x tending to 0 minus x, 1x will get cancelled. So, x sine 1 by x. This is again I am telling you sine 1 by x is bounded function, x is 0. So, 0 multiplied by any finite value will give you 0. So, this is done. Now, right hand limit x tending to 0 plus x square sine 1 by x, then again 0 because f0 is 0. You can see in both right hand limit and left hand derivative and right hand derivative, it is coming out to be 0 and f of 0 is 0. So, continuity, and you can see left hand derivative equal to right hand derivative, easily you can say this is differentiable, but in the beginning of the question we were just knowing that this is continuous only. Why this question is important? And now I will be just checking its derivative continuity. This is very difficult task anyhow. Let me just do this part, and it is very important from competitive exam. They give you 2-3 options because this function is differentiable also, and the derivative part is continuous or not. So, multiple choice you get. So, which option is correct? You should first you should know the complete solution, or then only you will figure out. So, what I am doing, I am taking the derivative. So, the function was x square sine 1 by x. Product formula you will be applying. Product formula you will apply. So, product formula says first same derivative of the second, sine 1 by x derivative is cos 1 by x, and the derivative of the angle is 1 by x. So, it is 1 by x derivative is minus 1 by x square, then plus the second function same, second was sine of 1 by x and derivative of x square is 2x. This is your derivative function. You will be checking the continuity of this function at 0. So, how you will be checking? This gets cancelled. So, minus cos 1 by x This question is very important from competitive exam point of view, whether you are appearing for NET exam or for IIT JAM exam, or even if you are pursuing BSc Honours Mathematics, BSc Honours Chemistry, Physics, BTech, this question is very important. You should know the concept. Now, this is the derivative. Check the limit now. I am checking continuity, not differentiability now. I am checking the derivative function continuity at x equal to 0. So, limit x tending to 0 minus. 0 minus means the function is same for x not equal to 0, so same function, but what is the issue? Just see the issue. Now see the issue, this limit. See, we know cos function is again bounded. This will lie between minus 1 and 1. This function is bounded, no issues. And this will lie between minus 1 and 1. Everybody knows in your 12th class you have already done it, minus 1 to 1, this function. But the problem is when you will go to the left, you know that the limit will lie between minus 1 and 1, but you do not know what exactly the limit will be. The same thing will happen जब आप right side जाओगे तो same ऐसे ही minus 1 to 1 में होगा. It means ये वाली जो limit है ना, it will not exist, and if this particular part is not existing, this limit will be 0. This has no issues because this is bounded, this is 0. So, when you will multiply a finite number with 0, it will give you 0. So, this because of this expression, this limit does not exist. So, f dash 0 limit does not, fx you can say, limit at this point of the derivative function does not exist implies it is not continuous. So, very good example, please practice it. F dash is not continuous. Many a time, number of times it comes in competitive exams, so you should be knowing. So, it means derivative when you are taking this expression creates the problem. So, because of that expression this is not existing. Now, I am just giving you the general formula for this, so that directly you will learn the values and you will be able to answer the question when it is coming in your competitive exam. So, what exactly the question is, learn it. I am giving you the general formula. So, suppose your fx is xm sine 1 by x. This is m sine 1 by x. So, I am taking any x here, x not equal to 0, 0 when x is 0. Now, I will give you the values of m, and for values of m you will get to know when the function will be continuous, when the function will be differentiable, and when the derivative will be continuous. So, just number 1. For continuity part, everybody, m should be greater than 1x, at least 1x you need. So, it means when you are checking continuity of this function na, for continuity m should be great, at least 1 m you need. It means if m is greater than equal to 1, no issues, nothing to do, you are very sure that this function will be continuous, because in competitive exams you do not get time, you are not you do not have time to solve, you should have idea. So, if m is greater than equal to 1, 101% this function will be continuous. Even already I have done it in my last lecture. Now, for differentiability, everybody, for differentiability, what happened? Because your definition is like this, your definition is fx minus f0, because 0 especially on 0 we are discussing, you get 1 in denominator, it means 1x gets cancelled. So, it means when you are checking differentiability, this expression becomes x to the power m upon f m. It means for the differentiability you are getting this expression finally, and if limit exists, it should be 1x I need, it means m minus 1 should be greater than equal to 1. So, for differentiability it means you need m should be greater than equal to 2. For differentiability m should be starting from 2, and for continuity it should start from 1. Now, the question is for the derivative, the last part which I did in the last question. For f dash, what does it mean? Dash we notate, or we give notation this what? Derivative. F dash continuity if you are checking na, So what is the what values of m should be taking? You can learn like this. It should be greater than equal to 3. So now from exam point of view, I am just taking one question. Now you will be easily able to answer. Suppose I am taking a question and the question is x square cube we take, and I am asking you, in the exam you are asked, you are given multiple choices. Number 1 is f is continuous at x equal to 0, f is differentiable at x equal to 0, and number 3 is f dash is continuous. As I told you, for continuity at least one m is sufficient, so it means it is continuous. For differentiability, the value should be x square and more than that, so it means this is differentiable also. Now for the derivative, I said the m should be greater than equal to 3, it means 3 onwards, so it means this function satisfying all the conditions. But if in case I change this 3 to, now you can see, suppose I am changing it to square. So what are the options which are correct? This is fine, but this is not fine. It means out of the 3, 1 and 2 are true, third one is not true. So in general I have told you how to check, and this is one of the very difficult problem, but I have tried that you understood it in a better way. So just learn these values, or you can just see the solution also. So for differentiability, this is all about differentiability, and if you will do these questions, you will have better idea about differentiability. So in this lecture, we have covered differentiability of a function, then some important results on differentiability, and side by side continuity results also I discussed. And then at the end, I have taken some questions which are very useful for competitive exams. If you want to study this topic in detail, you can refer to the book by S. Chand Publishing. The e-book link of which is mentioned in the description box below. Please don't forget to like, share and subscribe to S. Chand Academy. Don't forget to press the bell icon for future updates.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.